gRPC overhyped. Introduction. gRPC has emerged as a popular choice for building modern APIs, but confusion often surrounds its inner workings and when it truly shines. In this episode, we aim to clarify the protocol underlying gRPC, its communication flow, and when REST APIs might be a better fit. The foundation. HTTP 2 takes the stage. Contrary to popular belief, gRPC itself is not a protocol. It leverages the HTTP 2 protocol as its transport layer, offering several advantages over traditional HTTP 1.1. Multiplexing enables sending and receiving multiple requests and responses concurrently over a single connection, improving performance and reducing latency. Header compression reduces overhead by compressing request and response headers, further enhancing efficiency. Server push allows servers to proactively send additional resources, e.g., images, style sheets, anticipated by the client, improving perceived performance. gRPC in action. gRPC builds upon HTTP 2 by defining a structured way to exchange data. Service definition. Developers define service interfaces using a language-agnostic specification called protocol buffers, protobuf. This defines the data structures and methods, remote procedure calls, exposed by the service. And that is where gRPC shines. The ability to define interfaces and the ability to generate services and clients is a big win in cases where you have many services calling one another. So in this case, it's not the performance we are looking for. It's even a thing we don't look for, as it only makes things complex. It's the ease of generating clients and services from interfaces. Client-server communication. Clients marshal data into protobuf messages based on the service definition. Send these messages along with relevant metadata through HTTP 2 requests. What you don't see, unlike REST APIs, where you directly interact with raw HTTP requests and responses, gRPC hides the underlying byte streams exchanged between client and server. This abstraction offers several benefits. Language agnostic, protobuf messages are language independent, enabling seamless communication between clients and servers written in different languages. Improved developer experience. Developers focus on defining service logic and data structures, leaving the low-level communication details to gRPC. Error handling. gRPC handles error codes and messages gracefully, simplifying error handling for developers. However, this abstraction comes with a trade-off. Limited visibility. You cannot directly inspect the raw bytes being exchanged, making debugging certain issues more challenging. Imagine trying to understand a conversation happening in a foreign language without any subtitles or translation. While gRPC provides some debugging tools, analyzing the actual byte flow on the network can be complex and require specialized knowledge. REST against gRPC, choosing the right tool for the job. While gRPC offers performance benefits and streamlined development, it's not a one-size. In many cases, you can just stick with REST if you have a small set of services calling one another. However, in complex system where you have hundreds of services calling one another, gRPC as the straightforward outcome of using proto interfaces might be the way to go, as it's the default. Communication generated. You can consider however generating REST from proto, but that's not the main line.